Hi everyone. This lesson I'm going to demonstrate the question here. It's about discrete probability functions. So we have a spinner numbered from 0 to 5 and each of the 6 numbers has an equal chance of coming up. A player bets $1 for a turn at this game and you win $5 if your number that you selected has come up. Otherwise $1 is lost. We have to get the expected outcome. Now you might be tempted to go, the outcomes of this experiment are 0, 1, 2, 3, 4, and 5, and the probability of each of these outcomes is equally likely, so it's 1 in 6 for each of them. But the complication with approaching the question in this manner is that we don't know which number the player bets on. So the player could bet on the number 0 or they could bet on the number 1. It becomes difficult to come up with. So we're better off thinking of this as a sample space. These are the 6 equally likely outcomes when we have a turn of a game. Now what's my random variable going to be? In fact, I might change that X there to read S for sample space. Now my random variable X, I get to define this whatever I like. My random variable is going to be the player's profit. The profit that the player gets, or I suppose it could be a loss if it's a negative number. And what are the potential values then that this can take? Well, the player bets $1 and they might lose. So the value could be negative $1. The player bets $1 and they win $5. So the profit in that case would be positive $4. There's really only 2 outcomes when the person plays the game. They win or they lose. Now what's the probability associated with each of these outcomes? Well, they select a number, could be any of them, and there's a 1 in 6 chance that the number they select will turn up. So that would mean they win and they end up $4 better, or there is a 5 in 6 chance that they lose. So this is how I'm going to calculate the expected value. The expected value of X is the sum of the scores multiplied by the probabilities. So we have the number -1 by 5/6 plus 4 times 1/6. I end up with -1/6. This is in dollars. And so that's approximately 17 cents. It's a negative number. The player will lose in the long run. The expected value, or if you like, the average value for every game is a loss of 17 cents. Now in reality, sometimes they win $4, mostly they lose $1. And all those losing $1 more than counterbalances the occasional time when they win $4. In the long run, the player is on average losing 17 cents every time they play the game. Thanks for watching.